So the beginning of this part is going to be for fifth period because we got a little bit further in fourth period. So when we're dealing with complement, they want to know the not. There's a total of 25 students, and they want to know the probability of not studying a foreign language. So all of these studied a foreign language. 6 plus 3 is 9, plus 12 is 21. They want to know if 21 did study a foreign language, 4 did not. Okay? All right, in number 1, they want you to use probability with permutations or combinations. So it looks like, so take a second and read it, pause it, and it's combinations. It's combination because it said they just need to play the adds before the show. So whether it's the first one and then the second one, or the second one and the third one, it doesn't matter. So let me tell you what I mean by that. If I had 8 adds, okay, and I wanted to pick adds 2 and 3, that's one option. Adds 3 and 4, one option. But 5 and 6 is the same thing as 6 and 5 because we're playing it before the show. But if I wasn't focused on what was happening before the show and I was just playing the adds, then suddenly it would be permutation. Because if I played add 2 first and then add 3, or I played add 3 first and add 2, that would be different in how it was presented. Okay? So we know it's combination 8C2. So the formula for that is 8 factorial, 8 minus 2 factorial over 2 factorial. This is really 6 factorial. I could write this as 8, 7, 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1. But the repeat is at 6, 5, 4, 3, 2, 1. I just go 8 times 7, 2 times 1, 4, 28. That would be if it says how many ways, but it says what is the probability. So since it says probability, I need to put the line like that. It's a fraction. So they want to know what's the probability of playing both of the ones. Well, there's only one way, because if you play both of them, I'll be happy. There isn't multiple ways that I'll be happy. If I want you to play adds 5 and 6, I'm not going to be happy if you give me add 4 and 5. I'm not going to be happy if you give me add 6 and 7. I need 5 and 6. That's one option. Okay? Let's look at the next one. Each student receives the 5-digit locker combination. 1, 2, 3, 4, 5. This is fundamental counting principle. Okay? But then when it says probability, that means using the fundamental counting principle will give me that. Okay? So, my possibilities are 0 through 9, 0 through 9, 0 through 9, 0 through 9, 0 through 9. That's 10, 10, 10, 10, 10. My total possibilities is a 1 with 1, 2, 3, 4, 5. 1, 2. Okay? But now the probability of it being odd, well, let's look. If you have the numbers 0 through 9, 1 is odd, 3 is odd, 5 is odd, 7 is odd, and 9 is odd. That means half of them will be odd, which is 5 times 5 times 5 times 5 times 5, which is 5 to the 1, 2, 3, 4, 5. Let me turn it on. 5 to the 5th is 3, 1, 2, 5. Okay? Let me say that again. Odd numbers are 1, 3, 5, 7, and 9. So there's 5 possibilities for this one. 5 possibilities, 5 possibilities, 5 possibilities, 5 possibilities. Now what I want to tell you is, what if it said you couldn't repeat? Then that would be 5 times 4, because then if you use the 1, you can't use the 1 anymore. All you would have left is 3, 5, 7, 9. So that would be 4, 3, 2, 1. And then you would simplify, which I'm going to cheat a little bit. So 3, 1, 2, 5 divided by 1,000. Wait, no, just kidding. 1, 2, 3, 4, 5. 1, 2, 3. I think I got too many. And then go second PRB. Oops, I'm doing awesome. Let's try this again. 1, 2, 3, 4, 5. Second PRB. And it simplifies to 1 over 32. Okay? So let's go to the next one. The following numbers, what is the probability the number is greater than 17? So greater than 17 is this number, not 17. This number, this number, this number. I circled 4 numbers out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 out of 10 simplifies to 2/5, so there's a 40% chance. It's a pretty good chance that you'll pick a number greater than 17. So keep in mind, since it says greater than, 17 isn't included. All right, now let's officially get to the homework. Remember, I want you to pause it and then try the problem. Don't just copy mine. So sandwiches, sides, drinks, fundamental counting principle, and that's 60 choices. Okay. We got curtains, paint, bedding, fundamental counting principle. 10 times 8 times 20. 8 times 20 is 160. With a 0, 1,600 ways. First two, fundamental counting principle. FCP, FCP. All right, now we're talking about our rewards. So it's not fundamental counting principle anymore, okay? It's either going to be permutation or combination, but there's the option of silliest, best, and most creative. I think I cut and pasted this and forgot to change it. So it matters. If you're most creative, you will be upset if you got picked silliest. So combination would mean it doesn't matter. Permutation means it does matter. There are 8p, 1, 2, 3. 8 factorial over 8 minus 3 factorial, which is 5 factorial. 8, 7, 6, 5, 4, 3, 2, 1. That's out. And then now 8 times 7 times 6 is 336. And it looks like ways. Doesn't matter, you can write options. Okay. How many ways can a two-digit number, okay? So the total options for a two-digit number for 0 through 9, 0, 9. Oh, by using only the digits 3 and 7, and each digit is only used once. Okay, so I'm not using 0 through 9, I'm only using digits 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5. But it says that I can only use each digit once. So if I use the 3, all that would be left is 4, 5, 6, 7. That's 4 choices. 20 ways. Okay, let's go to the next one. 10 different color cubes. 6, so that's combination because it doesn't matter, you just need to choose them. So 10 factorial, 10 minus 6 factorial over 6 factorial, 4 factorial. This would be 10, 9, 8, 7, and then 6, 5, 4, 3. Done. So this would be 4 factorial, which is 4, 3, 2. You don't need the 1. 4 times 2 is 8. 9 and 3 give me 3. 3 times 7, 21 with a 0. Let's say options. Keep it interesting. Okay. Next one. Swim has 8 swimmers. They select 2. Wow, this is the exact same one. So we'll just say 8. So this is combination. It would be permutation if it was a relay, because who places first, second, third, and fourth is different. So that would be 8C2, so 8 factorial, 8 minus 2 factorial over 2 factorial. This is 6 factorial, 8 times 7 over 2, 28 ways. Okay? All right, we want probability. So since we want probability, we want a fraction. So I use the fundamental counting principle to figure out my options. Oh, you just have one die, so there's just 6 options. That's it. So what's the probability of getting an even number? Well, on a die, there are 6 options, and these are the 3 options that it could be. 3 out of 6 simplifies to 1/2. Find the probability of rolling a 7. You can't roll a 7. It's just not possible. And that's the homework.